Welcome back. This is another video on the Arduino source code. I had just performed the significant refactoring that I discussed in the last video with the goal of breaking up my over 300 line single source file. I had several design considerations I had to keep telling myself. The first one is that I am not creating any kind of dynamic system, any kind of abstraction to simplify things, although I did that a little bit. You will notice there is no new operator, there is no virtual operator. This is keeping with the mindset that everything is static, compile time, and most things are global. When we look at the sketch.ino file as it stands today, we have essentially 18, 17 or so lines of source code as opposed to 300. This keeps the single responsibility of this file very concrete and very well parsable. When you see this file, you see what it does. We create a scheduler. That's how I do the cooperative multitasking. I create my new object called city streets. When setup gets called, we immediately set up our serial and we tell city streets begin. It doesn't matter what components are inside of city streets, we tell it to begin. And as discussed before, our main loop function delegates to the runner to execute any scheduled tasks. So if we look at citystreets.h, the goal of city streets, his main responsibility is to declare the components that we use and start them up. So he has a constructor, he has the begin function. We pass in a reference to the scheduler so we can schedule tasks to be run. And then we instantiate the four components we use. We use Bluetooth Low Energy for our communications with our client applications. We use the matrix of LEDs on the R4 board. We have lighting and we have a servo motor. And his CPP file, his INO file is just as simple. We have the constructor and we construct each one of these. We construct the Bluetooth low energy by giving the advertised name. We construct our matrix R4 object. We construct our lighting object given the ports that we use. And then we construct the servo motor given the ports we use. When begin gets called, we begin each one individually. Each one of these components is broken up into its own individual class. So the first one that we're going to look at is the matrix class. So his single responsibility is to adapt the third-party Arduino LED matrix class to use Bluetooth Low Energy. No other logic exists in here. It's pretty simple. When we go and look at his INO file, his constructor takes one of these Bluetooth objects. We create the heart pattern that I have as my test pattern as the current value. And then we create the characteristic that we want. Now, this is the part where I simplified because I took a lot of duplicate code or duplicate pattern code and consolidated into a single function that creates a Bluetooth characteristic. So given that ID, given that value, and that function, update display to get called whenever the client says, hey, here's a new pattern to display on the matrix. Then his begin function calls the third-party begin, calls the third-party load frame with the initial value. We have the single function for that gets called when the client invokes a write on the Bluetooth property that sets the matrix. And then here's where we actually do the logic. If there's a change, update the hardware. Now, a couple of things to note in this file. The old code used C-style character arrays. Now that I'm adopting the C++ runtime, I'm using the standard array, which is a fixed size array of that type of unsigned int 32. And how this works is it is truly three integers just stacked right on top of each other. So you can treat it very much like a C-style array, a pointer to that block of memory. But you also get convenience things like condition checks and simple assignment. The old code did the C-style mem, copy and mem compares before. The other important thing to note, and I find this frustrating, but I don't have a need to solve it yet, is a lot of the Arduino libraries use function pointers, which says, hey, give me the memory address of a function to call. Now, which is what we're doing right there, update display. It's actually given the address, the memory address of this function. Now, this is a static function, which means that I really don't have a way to dispatch it during the function call to the appropriate object. So I set up a global variable, static, set it to null. When matrix gets constructed, he sets the global variable, and then I use the global variable to actually dispatch the function to essentially this. This works, but if I ever need more than one of these objects, I'll have to come up with a different pattern. But since there's only one matrix R4, this works. Now, normally in these type of APIs, you would be able to pass in like some kind of integer or pointer. So let's say, like 9 here, which means that this function would then get, like if it was just an integer, when this function gets called, it will be like int user value. And then I could use that 9 to then figure out, okay, what instance of this object to call. But that's not available. So, which is fine because I don't need to solve the problem today. Okay, so that's the matrix R4 interface. Now, all of this code used to be inside of the sketch.ino file. And when I do a compile of the new code, I am essentially the same 34% of usable space used on the device, which means I have not significantly grown, if at all, the program space with this refactoring, which is really nice. Okay, so the next file that we're going to look at is servomotor.h. Very similar, but just slightly more complicated. We construct with the Bluetooth Low Energy Service Runner. We have the members required to operate the servo motor with the business logic, and all of this was just copy paste from the old sketch.ino file. But instead of everything being a global variable, everything is now nicely encapsulated inside of these C++ objects. And then inside of his INO file, same pattern. We initialize all the members, including the Bluetooth characteristics with their IDs, their initial values, and any callback functions. When the client writes to that property, he has a begin. We set up our global variable. And then when the client says, change power or change calibration, we call update, which performs our business logic, as we kind of talked about before, where we handle the too little power going to the motor, don't bother turning it on, and then servo motors using this particular function to stop. The next class is lighting.h. Once again, same pattern, but slightly more complicated business logic. We have our our light output, which is what pin, and was whether it's a dimmable light or not. We are using a standard vector here, which is a high-level dynamic array where matrix was always 3. This is how many you want. Now, this likely does a heap allocation, but it only happens once, so I don't really care. The light sensor, or the ambient light sensor, and the Bluetooth low energy integration. And so, just like servo and matrix, his responsibility is to wrap the lighting task, or to adopt, not the lighting task, to adopt the hardware pins to Bluetooth low energy characteristics. So then when we look at his INO file, we initialize all the variables. Here we create a task because once a second, we want to read the sensor on the ambient light to know whether we want to automatically turn the lights on or off. His begin is to set up the hardware, schedule the task. We have the same pattern on the callbacks for the Bluetooth low energy writes, where we reference our global variable and we call our business logic. Same pattern on our sensing the ambient light. And then down here is our business logic, which was copy pasted directly from our old sketch INO file. But this is about 100 lines of code of the original file that's now nicely encapsulated into a single file or into a single class. So the next file is where I took all of the work required to manage the Bluetooth low energy service and encapsulated it into a single class. So we have a name, an optional service ID. Then I created these convenience methods to create characteristics. I'll show those in the implementation. And his private members is we have a name, we have ID, we have the third-party library that handles all of the difficult stuff for reading and writing values on the properties. And then, of course, we have our static methods for responding to events. So then I need to move this down. Move that back up. Thank you. Okay, so I'll talk about this function in a moment. So another C++ refactoring I did was I was using C-style strings before with the stir and copies and dealing with pointers. Now I'm using standard template library strings, which greatly simplified the code. And those may be doing some allocations depending on the sizes of the strings, but once again, it's all during setup, so I'm not too concerned. Then I initialize my members. His begin is, once again, a direct copy paste from the original sketch INO file. As we talked about before, his task is to, every 10th of a second, do BLE work. Now, if we go back up here, what this function does is it takes a name and converts it to a UUID string by looking at each character, converting it to hexadecimal, then putting in dashes where we need to put in dashes, and do some padding. This allows me to just simply have a name, and it will auto-generate a valid ID off of that name. And I call generate ID there. The next part that we do is on the characteristics. Now, creating a characteristic is a several step process. In the original code, we had, of course, make the characteristic, set the initial value, set the event handler, and add it to the system. So this is all now in one function. So this boilerplate code is not duplicated over and over and over again. I do my naming convention, where I take the first 8 bytes out of that ID and replace the service ID, first 8 bytes with it, and that's now the characteristic ID. If we have an initial value, we set up the permissions, because by passing initial value, we're essentially saying, yeah, the client, there's a value for the client to read. They can read, and we will probably write to it again so they can be notified if they want. If we have any event handler, that basically says, yeah, we're expecting the client to write values, so the permission is for them to write the value. And then we actually write the initial value, and we set the event handler, and then we add it to the system. So having this encapsulated has allowed me in like the INO file to have all of that logic just be those 3 parameters. To recap the changes, my goal was to get this from over 300 lines down to 17, to create components that I could reuse across different Arduino pieces inside of my Lego town. So like if beyond city streets, if my rail train, which will have an Arduino in it, has lights on it, I can use this code again without having to duplicate it. And the other big piece was I did not want to increase overhead, which meant that when I did just basic OO composition of breaking down all of those codes, all of that code into just basic classes with no virtual methods, no heap allocation. I just took the code from one spot, moved it to another, but now it's maintainable and parsable. And that concludes this video. Thank you.